Welcome to this course on Langgraph AI Agents, which builds on top of LangChain agents and is more powerful than just a LangChain agent because Langgraph gives us the ability to build stronger agents through the use of cycles. Just what are these cycles and why they are important? We learned throughout this course. So today we'll be learning about these cycles and how these cycles give us control flows to get LLM applications to obey a predefined chain of thought. By the end of this course, you'll be able to create a real-world agentic RAG application involving a complex cycle, a moderately complex cycle. So before we get into graphs and cycles and agents, let's just discuss what are AI agents and why do we need them. So agent is nothing but a fancy word to define how a human would go about thinking how to solve a problem. Here we see an example of a human who's trying to buy an ice cream. Without thinking so much about it, they would follow steps like identifying ice cream stores near them, visiting the first one, checking if they have the right flavor, and if they find the right flavor, then they would buy it. Just like humans, AIs also need a plan to execute anything. And here's where an agent comes in. An agent is a platform or a way for us to code an agent or code a piece of AI to follow steps which we as humans know are the best set of steps to solve any particular problem. Why do we need them? This kind of a structure, step-by-step conditional cycles, they give AI the structure. And then LLMs have already given us the ability to handle ambiguous steps. Clubbing both of these together, ambiguity as well as structure, is what gives AI the perception of human-like intelligence and makes for a much stronger application than just ambiguity handling LLM or just a heuristically driven structured software program. Let's see how that actually works out. What are RAG and what are cycles? RAG is short for Retrieval Augmented Generation, which is nothing but a very fancy term for when an AI system has the ability to augment their generation by retrieving information from outside their knowledge base. Even here in this example, we see for a human who's trying to buy an ice cream and in his current knowledge base doesn't know all the shops which sell ice cream, he can look up Google Maps or other tools to Yellow Pages, etc., to find out the shops which sell ice creams. And that's the step one, which we have indicated here. This represents the retrievals in a RAG. And when an AI system does it, we call it retrieval. When a human does it, we don't call it anything, because that's just the way humans behave. So representing all of this agentic flow in a graph, we see that the agent searches for ice cream shops, they identify a list of such shops, visit a shop, starting with the first shop, check if they have the right flavor, go back, visit the next shop, and so on and so forth, and till the point that they find their favorite flavor and then they buy it. This yes, no is an example of a conditional edge, and this no going back to the shop is the example of a cycle. And that's about all we need to know about cycles and retrieval augmented generation. Now, let's see how Langgraph allows us to coach AI agents to be able to perform these kind of cyclical workflows. Langgraph gives us three vital components. The first of it is the state. So it allows our agent to store where it is right now in its execution of a particular problem statement. For example, in our ice cream purchasing problem, the agent could be at the stage where they are searching for the ice cream shops and they've searched and then they're planning to visit a shop. So that's an example of a state. They have visited a couple of shops. They haven't found the right flavor yet. So that's an example of a state. So state basically tells us where we are. Nodes are actually the building blocks of our system. So searching is a node. Visiting a shop is a node. Buying it is a node. So these are the actual action blocks where stuff happens. Edges define how the workflow moves from one node to the other. In some cases, it will be a straightforward edge, such as after you're done searching, you have to visit a shop. In some cases, it could be a conditional edge. In this, for example, if the flavor is not available, then we have to go back. This is an example of a conditional edge. Let's look at some examples as to how these tools and cycles come together. As I was harping on earlier, Langgraphs gives us the ability to define these tools. Tools are the ones which are doing the retrieval on behalf of our LLM. It's as simple as giving the definition of the tool and telling Langgraph that this is one of our tools, and then calling it later and sort of defining it and allowing the LLM to call it as part of a node. On the left is a very simple tool which adds two numbers in case the LLM didn't know how to do that already. On the right is a slightly more complicated tool which performs an internet search. I've included both to show that the actual tool definition is quite straightforward. Whatever you want to do inside the tool will determine how complicated that tool code is. Moving on to the heart of the Langgraph, which is an example of building cycles and conditions. So this is a problem statement where a user is trying to write a research paper. In their profound wisdom, the user has decided that this is how the flow should be. We should start with a plan. After that, the plan should get researched, possibly using the internet. And then using all of this research, the paper should get generated. After that, there should be some reflection and critiquing of it, whether this paper is good, whether the content is good or not. If no, then the generation needs to happen again. What's not included here is that the generation may trigger a request to another research as well. For the sake of simplicity, we have not included that here, but that's possible. But what we see an example of is a elementary graph with cycles and conditions coming out of it. Look at the code on the left. These 12 or 13 lines of code is all it takes to construct this kind of a graph with conditions and cycles. Whatever goes inside of these planning and research is a tool, depending on how you want to do the research, whether it's online, offline, etc. And then that can also happen. That gets generated separately. But what I'm saying is that these 12 lines are all it takes using Langgraph to build this kind of a cyclical agent. Demo, we have no time. Conclusions. Okay. So today we learned how to create a simple cyclical chain of reasoning to accomplish complex tasks using an LLM. Next steps would be try out open source repos on GitHub with interesting Langgraph applications, trying GUI tools, and creating real-world examples of agentic rig applications yourself. Thank you, and hope you learned something.